So welcome to this video. This one is a requested video for this question number 8, that is paper 2017 May-June paper 2-2. Okay, so here we have A, B, C, D. This one is a cross section of a building. Now all the lengths are in meters. Okay, first question is to find the length of DC. DC will be this length. So here one thing we could do is we can try to move up DC. Let's say DC is here, we move up DC until here. So that will be the same as DC, and let's say this is 90 degrees. So let's call this X. So XB will be the same length of DC, and here we have EXB as a right angle triangle. So if this length is 6 and this is 4, this will be 2. So you can find the length of XB by using your Pythagoras theorem. So let's do that. So you will have, so we know that XB square plus 2 square is equal to 15.1 square. So from this we can find XB square is equal to, so what is 15.1 square minus 2 square? That should be 224.01. So XB will be square root of that. That should be 14.966. Now we know that XB is equal to DC according to the diagram. So DC is equal to 15.0 meters, correct to 3SF. Okay, so that will be your length of DC, 15 meters. Now for part B is to find the angle EAB. So EAB, so E is here, A is here, B is here. Now if you observe for this one, we have a triangle EAB triangle. We have these two sides and we have this side. We have to find the angle. So let's call this angle theta. We can use your cosine rule, right? So you would say cosine of the angle is equal to 9 square plus 11 square minus 15.1 square divided by 2 times 9 times 11. So let's solve this. 9 square plus 11 square minus 15.1 square divided by 2 times 9 times 11. That should be cos theta is equal to minus 0.131. Theta will be cos inverse of that. That should give you the angle. So we have to use degrees. So cos inverse of minus 0.131, about 97.5 degrees for this angle of theta, which is EAB will be 97.5. Okay, that was pretty forward, but of course we have to show your work in this space right here for your marks. Okay, now for part C we have to find the area of the cross section. Now if you observe the cross section, we can break this down into two parts. The first one is a triangle, and then second one will be a trapezium, right? So first one, let's find the area of the triangle. So area of triangle, so area of triangle EAB. Let's do that. So this will be half sine of the angle we just found, so 97.5 times the two sides, which will be 9 and 11. So half sine of answer times 9 times 11. That should be 49.07 meters square. Now what is the area of this trapezium? We can find this. Area of trapezium, that will be trapezium EBCD. We have just to use a formula for that. So half times sum of the parallel sides. So these two are parallel sides. That will be 6 plus 4, and times the length in between. That will be 15. So this will be 10 too. So that will be 5 times 15. That should be 75. So area of the cross section. So area of cross section will be this plus this, right? So plus 49.07, that should be 124, correct, to 3SF, 124 meters square. Now moving on to part D, I think that's the tricky part to understand. It says a model of this building, of the same building, is made using a scale of 1 to 50. That's just the scale. Scale is linear, which means it is meters, right? Okay, now what is the area of the cross section of this model? Give your answer in square centimeters. So first thing you need to know is that, let's keep this as a side note. You need to know that 1 meter square is equal to 10,000 centimeters square. So you have to keep this in mind for later on. But first, let's convert this. So we have 1 to 50. That is your model, and that is your actual area. So this is the actual building, so the model actual building. So now the scale is in meters, but you have to find the area. What is the unit of area? You would say area is measured in meters square. Now, how can you convert meters to meters square? You have to square it. So same thing, you have to square this, and you have to square this. You will have 1. What is 50 square? 50 square will be 2500 meters square. So now the ratio from this, we found out the ratio of the area is 1 to 2500. That is for the actual building, that is for the model. Now we know that the actual building has area 124, so it means that A is 124 for the actual value. So we have this ratio, we have to find this one. So we know 2500, that is this ratio, is equal to 124 meters square. We're trying to find this one for the model. So what is 1? 1 will be 124 divided by 25 times 1. That is in terms of meters square. But now your answer has to be in centimeters square. And to convert meters square to centimeters square, we have to multiply by 10,000. So that will be 124 over 2500 times 10,000 to make it become centimeters square. So let's do that. 124 divided by 2500 times 10,000. That will be 496. So your answer correct to 3SF will be 496 centimeters square for the area of the model. And that was question number 8. So I hope that was somewhat helpful. If you guys have any other questions, leave a comment down below. I will get back to you guys as soon as possible. As always, thank you for watching. I will see you soon.